All right. Good evening, everybody. Thanks so much for joining us tonight on our WaterWatch lecture series of 2023. I've been having a great turnout and really appreciate you joining us tonight. My name is Brian Taylor with the North and South Rivers Watershed Association. And if you are not familiar with the NSRWA, we are just a small local grassroots nonprofit. Our office is in Norwell, but we work all throughout the South Shore in preserving and protecting one of our most valuable resources, water. And so if you're interested in the organization, unfamiliar, our website is there in the corner, or feel free to email us at any point. You have our email if you have registration for this. And so we'd love to take any questions or maybe even possibly have you as a member. So, and if you are a member, thank you so much for your support. We've got a great program tonight about salt marshes. But before we begin, I'd just like to say a brief thank you to our sponsors. And so this program, the series, has been sponsored by Clean Harbors, as it has been for several years now, the Clearwater Recovery, and the Mass Cultural Councils of Duxbury, Hanover, Marshfield, Norwell, Pembroke, and Plymouth. Thank you so much to your support for educational programs like this. We've had amazing turnout. We've been averaging about 80 to 100 or so people for each of these sessions, but we've been having hundreds and hundreds of folks watching the videos, the recordings afterwards. We have about 1,040 individual registrations for the program. So it's just, the turnout has been incredible. So thank you all so much for your interest in our programming and for tuning in with us. So as usual, I would like to introduce my partner in the WaterWatch lecture series for several years now. I'd like to pass it over to MassAudubon's Doug Lowry.
Thank you, Brian. Yes, and we are excited. This is the 7th in 8 of this year. And as Brian says, they've been really well attended. And we'd just like to shout out and thank you so much for the last few years for being willing to kind of pivot to this online programming. Many of us miss the ability to meet in person. We certainly, had a very community flavor to it, and we're grateful for you to be flexible like that. However, this year we did start this series with an in-person program, and we're going to finish next week with an in-person program, and it's going to be a climate cafe at Stellwagen Brew Company on Enterprise Drive in Marshfield. And we hope to see you there. It should be a great event. If you want hope, then it will be a great venue for you to attend. And there'll be a lot of folks, kindred spirits there. And we will discuss ways that we can get our head around climate change and find positive ways to impact our future. And yeah, we're very grateful once again to partner with the North and South Rivers Watershed Association. I say this every time, our community would not look the same without the work that Sara and Brian, Sam, and everybody there at the Watershed does. So yeah, looking forward to this evening's program, and back to you, Brian.
Thanks, Doug. Same to you and MassAudubon. The sanctuaries all around the South Shore are just incredible places to go and visit and engage with nature. So same to MassAudubon. Shout out to you guys. So without further ado, I would like to introduce a really exciting panel for tonight. So tonight's topic is making salt marshes more climate resilient. And so tonight we have geologist Tom Bell. We have NSRWA's Watershed Ecologist, Sara Grady, who is also the Mass Bay South Shore Regional Coordinator. And we also have Danielle Perry with the National Oceanic and Atmospheric Administration, a Marine Habitat Resource Specialist. So tonight, restoring, healing, adapting our local salt marshes to withstand rising sea levels will be important to maintain their ecological values in a changing climate. Not only we're going to be talking about making salt marshes more climate resilient and restoration and how we can apply these practices here in the South Shore. But Tom Bell, our geologist, is going to be, he has been analyzing some historic aerial photos of 1952 compared to around 2015 of the salt marshes. So he's going to share with us some of these findings that he's been analyzing in regards to how salt marshes have been changing in those past 50 or so, a little bit more than 50 plus years. So we're really excited about tonight's program. And with that, I would like to send it over to Dr. Sara Grady. Sara, why don't you go ahead and take it away?
All right. Hello, everybody. This is going to be pretty exciting because there are three of us who are presenting. And so we'll kind of pass it back and forth and give you some info on what we've been up to in the North and South Rivers and some of the strategies that have already been working in other parts of the state that we are hoping to be able to implement here in our watershed. So just to start, wait for my slide to advance. There we go. Oops, go back one. All right. So when you look at a salt marsh, you'll often see that there are sort of these bands of vegetation. And this is an important place to start with understanding how salt marshes work. So in our classic idea of how salt marshes are zoned, there are pretty much three parts to a salt marsh. There is what has been called the low marsh, where we have salt marsh cordgrass, Spartina alterniflora. There's what we have called the high marsh, which is salt marsh hay, Spartina patens, and then the upland, which often has this high tide bush, Iva frutescens, as well as in some of our marshes, Phragmites. So in a basic way, as sea level rise occurs, we would expect to see the more salt and water tolerant low marsh start to migrate into areas that are currently occupied by high marsh. And there may also be places where that high marsh grass might start to die off because it's getting flooded out and can't tolerate being underwater for that long. In addition, we might also start to see some bank loss with sea level rise because when we lose that vegetation at the edge, that mud or that peat becomes more vulnerable to erosion. And so that is kind of what Tom has been taking a look at, looking at exactly how we may have lost those edges over time. So now I'm going to pass it off to Tom to explain what he's done.
Thanks, Sara. Let me share my screen here. And hopefully this right there. Does that look okay?
Yeah, looks good to me, Tom.
Great. So thanks everybody for attending. This is, I think, a really interesting subject, something that I've come late to. I'm certainly not an expert on this like Sara and Danielle. I'm a geologist rather than an ecologist. But the tools that I've learned as a professional geologist are applicable to understanding how the landscape changes through the use of some tools like LiDAR imagery, or LiDAR elevation measurements, geographic information systems, GIS, etc. Some weeks ago or months ago now, Sam Woods contacted me and wondered if it were feasible to measure the marsh loss in the North River. And I said, yes, if we could get some older photo imagery from the area, we might be able to measure that and then compare it against some more recent data. And she immediately introduced me to two citizen historians, Lyle Nyberg and Jim Glinsky, who had already been experimenting with this, and they helped me find some imagery that the state has, actually UMass Amherst has, and it dates from 1952. So I plunged into this sort of casually, not quite appreciating how much work it actually was. So let's start by taking a look here. So the modern data is really pretty simple. Post Hurricane Sandy, NOAA flew all the coastlines of the conterminous United States with the objective of determining which areas are prone or vulnerable to coastal storms. And they did this with a method called LIDAR, light detection and ranging measurements, which essentially measure the elevation of the ground when the final product is on a meter by meter basis. A meter is about a yard. So every square yard, we know the elevation of. This is really remarkable data. It is accurate to about 10 centimeters. And what you see here is a relief map that I created of the North and South River. I have my little LiDAR image down here, and you can see basically they fly it with an airplane and they bounce a laser beam off the surface, and it returns to the airplane, and they can measure the time it takes to return and therefore calculate the elevation. I won't get too much into the details because it's a fairly arcane subject, but you can see here from the Indian Head River, we can track our way down the North River through Route 3. It starts to become, if you can see this on your screen, you can start to see the channel a bit as that elevation drops in the channel and to the outlet. So a number of tidal creeks. This is the South River. So these data were collected, flown of 2014 to 2015, something like that, and published in 2016 by NOAA, and it's available on NOAA Digital Coast. It's free to everybody. So with those measurements, determining the current extent of the salt marsh is actually fairly straightforward. What I did was to select contour lines created from the digital elevation model. Again, I know the elevation of every square meter here, and I can create contour lines just like a topographic map, and then start to match them against what I can see on current imagery. So by trial and error, I determined that the upper margin of the high marsh is at about 5 feet above sea level. And the lower edge of the low marsh is at around 3 feet. So after I had fitted that, then I could create this pale green image of the salt marsh as it exists today. The total area is about 2,025 acres. That's just the North River. We're not going to talk about the South River at all. As a preview of what we're going to get to, we have lost about, by my calculations, about conservatively, very conservatively, about 220 acres between 1952 and 2015. It's not so easy in 1952. We didn't have LIDAR in those days, so we don't know the elevation in 1952. And believe me, it's changed as the river has changed course or erosion has taken place along its banks. The contours in 1952 would have been quite different from the contours in 2015. What we do have is aerial photography from that era. This is I won't call it a primitive technology, but let's just say it's not as sophisticated as LiDAR imagery. We still do a lot of aerial photography. You see it all the time on Google Earth, Google Map, various other platforms. And this was commissioned, a survey of the entire state of Massachusetts was commissioned sometime in the early 50s and flown in 1951 and 1952, and then archived. Unfortunately, much of the information that would enable us to locate these images in space or on the ground has been lost. So it's a matter of trial and error again to make each one of these 2,000 by 2,000 foot squares that I've cut out of the original imagery to fit. So that turned out to be quite a hurdle to cross to be able to then digitize or trace the boundaries of the salt marsh. Here's an example of what 2021 and 1952 imagery looks like. You can see in exquisite detail on the 2021 imagery, and you can see this in, you know, Google Map or Google Earth anytime you want to tune in to it. 1952, things are a little bit trickier. You can still see detail. You don't have the advantage of color, so determining the edge of the marsh becomes somewhat more difficult, but not impossible. The water in these black and white images shows up as very dark gray to black. So you can see the tide was out when this photo was taken. You can see that this tidal creek is pretty much empty. This is what's left of standing water in it. Fortunately, the mudflats have a different reflectivity than the marsh itself. So the marsh itself here is this medium gray color. The light gray are mudflats. There's no vegetation on them. And the black is standing water. So to go from 2021, I don't even need the imagery. I can use that digital elevation model to determine this boundary right here. This is the edge of the marsh. Okay, here I can also do that by looking at the edge between the gray, medium gray, and the light gray or white, if you will. And so in this case, I can arrive at the contours from the digital elevation model. I don't have to trace anything. It's really easy. Well, at least from a hours put in easy perspective. So this image is representative of how I conducted the investigation. These dark black lines are the 3-foot contour from the digital elevation model. These are highly accurate, plus or minus 10 centimeters. And what I did was I tried this by trial and error. I would adjust this line by picking maybe 3 feet or 3.1 feet or 3.2 feet, 2.9, 2.8, until I found something that matched the image that exists for 2021. Now, bear in mind, this is 2015 elevation data on a 2021 map or image. So certainly there's a little bit of error involved in this. The yellow line is what I've actually traced in the 1952 images. And this is a tedious job, as you'll see in a couple of minutes, but fairly accurate in some places where the imagery is good, where the resolution is high, the contrast can be adjusted so that it's high. I was able to trace the 1952 margins of all of these features. So the red zones in between are marsh that's actually been lost. This can be quantified because I can create by a certain processing technique, I can calculate the area of every one of these red areas and therefore calculate how much marsh has been lost. So that's how it's done. Here's how it came out. So let's start at the Indian Head River and hop in our canoe here at the canoe launch and go downstream. And you immediately see that there are large areas of red here right at the headwaters. I've heard anecdotally that people are saying that the marsh is filling in here. Well, the evidence from the images seems to suggest that the banks are collapsing. That doesn't mean that the marsh is filling in. In fact, it is filling in the sense that the high marsh is collapsing into the channels and they're probably getting shallower. So any of you that have canoed and turned right down here at the fork, that's probably what you're seeing. So you can see quite a lot of marsh has been lost here, even along the main stem of the North River. And these tidal creeks as well, quite a lot of loss here. Anytime you see big areas of red, that means that marsh has been lost in those areas. So as we travel down here, we get into the meander, all these meanders here, and we start seeing a much wider marsh. You can even see it here pretty easily in this 2021 image as distinct change in color between the wooded uplands and the marsh itself. It's at this scale, it's hard to distinguish the high marsh from the low marsh. So we're not going to go there with that, but you get some notion of it just maybe from the color here, I suppose. And so notice that the inner bends of these meanders tend to be losing bank. The errors in this are generally due to low resolution in the 1952 images. So in some cases, I wasn't actually able to digitize some of these, even some of these larger tidal creeks and ditches. But you can see this is 44 acres. That's about 25% of the 220 acres that have been lost. So let's move downstream from Route 3. We're going to get into another area of meanders. This is oriented north and south. So I call it the long reach. It's north and south. It doesn't end here. It just picks up here. It's so long that it just wasn't going to fit at any kind of detail in my presentation. So I had to cut it in half. But again, you can see that there are still a lot of ditches here that don't have any red in them. That's probably because I'm not able to recognize, even see the ditch in the 1952 photos. So this is where my conservative estimate really comes in. In some cases, I'm just not able to evaluate areas like this or this tidal creek. And so there's really not a lot of red out here in the marsh itself, in the ditches and the tidal creeks. But you can see significant losses in the main channel of the North River. So that takes us to Bridge Street, and things are going to change significantly now. We went from a north-south oriented reach to an east-west oriented reach. And fortunately, the historic photos improved considerably in terms of their contrast and resolution. So I was able to actually digitize more accurately and quantitatively more of the ditches and tidal creeks. And suddenly it really starts to light up with red. You can see that there's been losses all along. I don't even know what the names of these are, but I'll confess that I really haven't been out here in the field very much. I took my boat up here once a long time ago, but really don't know the North River except for through these images. So in that sense, I guess there's no bias here since I haven't seen it in the field, but it would be nice to field check some of this stuff. In any case, you can see that the losses are increasing to some extent as the channels get narrower in the tidal creeks and certainly in the ditches. So this is going to be a very short talk because we're almost to the inlet here. I just say that this represents about 12% of the original area in this, right in here, not of the whole area, but 12% in here. So let's make our next step forward. And this is where it really, to my mind, gets pretty interesting because there are two real drivers here in marsh loss. The first one is anthropomorphic. You can see a large yacht basin was carved out of the marsh here. This was all pretty much, it wasn't pristine marsh, but it wasn't as highly impacted as when they dredged it and put in a yacht club or whatever's here right up. This is New Driftway here, by the way, if you know your geography. I didn't show this whole reservoir here, but a dam was built across the marsh here. And so there's no marsh loss except in the sense that it's flooded by this reservoir. And the same thing has happened down here. It was marsh all the way up here, and now it's been flooded when this dam was created. Interestingly, there were a number of marsh islands out here in 1952, and they're completely gone. They've disappeared. There's been a lot of erosion here, clearly, and here, and this is all probably a function of the changing tidal regime as the marsh changes. Of course, the channel moves one way or the other, and so some places are impacted more than others. This area here is an obvious place where you would expect to see marsh loss because it's a northeast facing marsh, and with nothing other than the bar here to protect it. So high tide, imagine high tide, nor'easter, storm surge. This is really the front lines of the marsh, and we're losing ground here in a serious way. And similarly, here the marsh used to extend all the way out here, and it's no longer there. The marsh still exists. In fact, it's been replaced by a sandbar. The remnants of the marsh still exist here. You can still see the tidal creeks, and at low tide, it still exists, but there's no marsh vegetation. There's no spartina here at all. It's just mud flats, but there's still incised ditches and tidal creeks within it. So again, it looks like there is maybe some correlation between inverse correlation between marsh loss and the size of the channel. In other words, the channel gets narrower, it's more prone to marsh loss than the wider areas. And it's just speculation on my part. It looks like that to me. What else do I want to say here? Okay, so the losses here were 128 acres. So this is more than half of the total loss to the North River system. So with that, you have the data, and I'm going to leave it to Sara and Danielle to maybe explain some of this or offer what they can. So thank you very much. Oh, I do want to acknowledge before I go the Town of Scituate archivist who showed us some really interesting archival photos. They're very large format, 1974. It would be interesting to get into that as well and see what's happened since 1974. And the University Archives Research Center at UMass Amherst, who preserved all these 1952 photos and provided them to me. And again, I want another shout out to Lyle and Jim for really getting me started on where to find these photos. So with that, I'm going to turn it back. Thank you very much.
Thanks so much, Tom. That's absolutely fascinating. I've already seen several questions coming in. Please, if anyone has a question, put it in the Q&A. We'll try to spend some time to get to it afterwards. But I myself have some questions too. So fantastic work, Tom. Thanks so much. Sarah, you should go ahead to take it away.
All right. So where we left off, we were talking about vegetation loss and bank loss, and Tom just talked to us about some of that bank loss and where we have seen that happen up until now. And I wanted to get back into talking about looking at our marshes and our marsh zonation and how that's a bit more of a complicated story, and some of the things that we're trying to do at the Watershed Association. So about 6 years ago, our colleagues, our salt marsh science colleagues, kind of discovered that the zonation that I referred to earlier is no longer so straightforward. We found that generations of farmers in the 1800s had altered our marshes. So it wasn't just the 1930s mosquito ditching, and that our salt marshes will show degradation when they are inundated, and something like a mosquito ditch is a way for that water to reach parts of the marsh that it otherwise wouldn't. There are also these farming impacts still present, and they correlate to those areas of degradation. So anyone who attended the talk with Sue Adamovich last year heard a lot more detail about this concept of farming in the marsh and how it's affected our marshes. But unfortunately, those places where we are seeing marsh loss and degradation are also the places where there's salt marsh sparrow habitat. So in the high marsh. So that has gotten a lot of attention from federal agencies and state agencies who are interested in preserving that now vulnerable and somewhat endangered high marsh habitat and the vulnerable salt marsh sparrow. So now, since we have sort of this patchy distribution of marsh zonation, terms like high marsh and low marsh are not quite accurate anymore. So what are we trying to do to find out more information about what has happened to our marshes and what is happening to our marshes? Well, the North River is a great place to study salt marshes because not only can we look at how vegetation changes happen from a river to upland gradient, we also have this great riverine gradient that Tom just showed. And so as you move upstream, we move from salt marsh plants, the two Spartinas in green and blue here, as well as some Phragmites, up into more brackish marsh plants like bulrushes and cattails. And so those are places where we might see marsh migration occur as sea levels rise. We might see the salt marshes start to move upstream. We've collected data using traditional marsh transects. I actually studied the marshes of the North and South Rivers when I was an undergraduate, and then I returned to look at those transects again, and we have seen in some places up to 80% of the high marsh replaced, or I shouldn't say high marsh, of the salt marsh hay, the Spartina patens, replaced by cordgrass or Spartina alterniflora. I also currently have my Salt Marsh Sentinels program, and I believe some of my sentinels might be listening tonight, where we're using homeowners' docks as a transect to look at how salt marshes are changing up and down the river corridor. Anyone who's out on the river can keep an eye out for ghost trees, which are dead trees along the upland border that are now either receiving too much water or also receiving too much salt water. And so if you start to see trees die in your own yard or as you're out for a paddle, you can report those to me at the Watershed. And we're going to start trying to map those out. And then finally, I'm going to be starting to do a desktop analysis of the marshes in the North and South, as well as throughout the South Shore, comparing a bunch of different data sets to determine vulnerability and try to create a prioritization for restoration. So some of that data would be the LIDAR that Tom mentioned. There are sea level rise models that will show how sea level rise might affect marsh migration. We have historical maps, we have aerial photos, and then there are also existing prioritization tools looking at things like salt marsh sparrow habitat. So combining all of those things, we might be able to get a sense of where we should look next for restoration. So now I'm going to pass it off to Danielle to tell us a little bit more about how we would go about restoring that natural marsh hydrology.
Great, thank you, Sarah. So as my description says, I currently work for NOAA, but up until about 4 weeks ago, I worked for MassAudubon. And so through this presentation, I'll be sharing some of the work that I've done at MassAudubon, as well as an ongoing salt marsh restoration project at their Allen's Pond Wildlife Sanctuary in Dartmouth. Next slide, please.
Yep, it's just slow to advance. Hold on. Hold on, hold on. Come on. It's gonna go, I swear.
I believe you.
I'm hitting the key. All right, let's see. Go. All right, hang on. Clicking on it. There we go. Okay.
Perfect. So I just wanted to start off with this term called climate change adaptation. So, and it describes the type of management action that addresses climate-related vulnerabilities for susceptible habitats and helps those habitats prepare for, cope with, and respond to climate change impacts. And because we're talking about salt marshes today, these climate change adaptation techniques that I'll be speaking of have to do with what types of restoration actions, what types of adaptation actions can be implemented to help salt marshes become more resilient to sea level rise impacts. So there are two techniques, ditch remediation and runneling, which are also types of hydrological salt marsh restoration that really work hand in hand and have shown to be effective methods to help revegetate salt marsh areas that have experienced die-off due to excess flooding caused by sea level rise. They also help to promote salt marsh growth and enhance overall resilience to sea level rise impacts. And the purpose of these techniques is really to restore the natural hydrology of the salt marsh. So as Sara mentioned before, these marshes have been historically altered, not only for mosquito control purposes, but dating all the way back to the 1800s when it comes to agricultural and farming. So these techniques really are implemented to go back to how the marsh wants to operate, to kind of restore its natural hydrology, single channel hydrology, which then ends up making it that the marsh is more resilient to the impacts of sea level rise and prevent any further loss. So the sites that I have listed on this slide are just a few projects that have occurred in Massachusetts and Rhode Island, and I'll be sharing some photos and results of these projects throughout the presentation. You can go to the next slide, please.
It's being very slow. I'm sorry. Let's see.
So the first of these techniques being ditch remediation. So ditch remediation uses natural plant material sourced on the same marsh where implementation occurs, and implementation of restoration. And this plant material is used to fill these historic ditches or heal them. And these ditches, as mentioned before, were used for mosquito control purposes, created for historical agricultural and farming purposes that Sara spoke of. And these past actions have shown to lead to marsh sinking and loss of elevation. And that's the opposite of what we want to happen with our marshes, especially when we think about sea level rise. Because with sea level rise, if we are losing elevation, it just makes marshes more vulnerable to the impacts of sea level rise and less capable to protect themselves and withstand the impacts of sea level rise. So we don't want to see our marshes sinking. We don't want to see our marshes losing elevation, which has shown to be an effect of these extensive ditching that has occurred on our marshes. And so we fill these ditches with natural plant material, as you can see from the photos, which then helps them promote marsh accretion and marsh growth, which is what we want to see when we're thinking about sea level rise. We want our marshes to grow. We want our marshes to grow vertically because that helps them become more resilient to current and future impacts of sea level rise. So if you take a look at the photo on the left column, you can see a treated ditch. And so just over a course of a year, that ditch is no longer noticeable. So being able to treat a ditch with natural plant material allows it to naturally then fill in within itself over time, trap more sediments, trap more material to allow that ditch to heal itself to the point where you can no longer see that ditch footprint. And then later on further promotes that growth of the marsh even after implementation has been completed. So these processes, as I mentioned, restore that single channel hydrology in the marsh, basically allowing the marsh to function the way it was supposed to before the creation of those ditches, restoring conditions that make the marsh more resilient to sea level rise, which I can't stress enough. You can go to the next slide, please. So how does ditch remediation work? So this is basically a fancy lawnmower. So and then the picture is Jeff Wilson, who does a lot of the ditch remediation work. And he's basically mowing salt marsh hay, which is a practice that is still done to this day, just for various purposes. Salt marsh haying is kind of like a cultural practice within New England. So he's just cutting the salt marsh hay, the Spartina patens. And then after cutting that material, it is then, you can go to the next slide, please. It is then raked into the ditch. And you can go to the next slide. And then once it's raked into the ditch, it's then secured with twine. So you can kind of see that twine within the photo. And then this practice is done over multiple times within a growing season or within a summer. And then it naturally is then able to fill in and heal over time on itself as well. And so the next technique wanting to talk about is runneling. So runnels or micro runnels, we often hear the question of what's the difference between a ditch and a runnel. And so the main difference is that runnels are typically shallower than ditches. And because of that, do not have the same adverse impacts that ditches do. And so overall runnels are shallow channels strategically placed to drain water impoundments that have formed due to sea level rise and also due to clogged and unmaintained ditches. So these water impoundments, which are basically resting pools of water on the marsh that do not drain even during low tides, and salt marsh vegetation die off as a result. And if left unchecked, these impoundments will just get larger and larger and put our marshes at risk of becoming a mud flat. And also due to these impoundments, we're losing very valuable salt marsh ecosystem services like carbon sequestration as the plants die and the sediment erodes. And so these runnels, they drain these water impoundments, they drain these pools to promote vegetation regrowth, sediment stabilization, marsh vertical growth that help maintain vital salt marsh services and prevent further erosion or degradation. So these processes is you can see illustrated within these photos. So it can be done either using shovels. So often this is a big volunteer event where folks can help dig, excavate runnels using shovels, handmade tools or hand tools. And so in the bottom right photo, you can actually see the full process of a runnel being implemented. So that photo at the top of that frame kind of shows the before picture of the water impoundment, the die off of vegetation. That in this situation, an excavator was used to create that runnel, that shallow channel. And then you can see in that photo, just over, I think that was about 2 summers, the amount of vegetation that has come back, the pooling that has decreased, and you can no longer see any more standing water. And that's what we like to see, and that's why we like to use our runnels, because it helps promote that vegetation growth and eliminate that excess flooding and flooding stress that the vegetation is under. Go to the next slide, please. And so this is just another project. This is a photo from a project in Little Bay in Fairhaven. It's completed by the Buzzards Bay Coalition. So you can see from the photo just after one growing season, the amount of drainage and plant growth that has occurred due to the implementation of runnels. So another example of how runnels can be used to help eliminate those water impoundments and to promote vegetation growth. Next slide, please. And so I'm going to go delve a little deeper into a specific project. This was actually the focus of my PhD dissertation, looking at a salt marsh within the Narra River in Rhode Island within Narragansett. And so I'll talk to you about like the high Cliff Notes version of the project and what we found. But if you care to read up a little bit more detail there, you can look at restoration ecology, and it has more details for that paper that you can see there. So you can go to the next slide. Thank you. So you can see from the photo, this is the Narragansett Bay, if folks are familiar. But then the little icon there shows the Narra River where the location of the project happened. And you can go to the next slide. So the purpose of this experiment with the runneling technique was to see how runoffs were impacting salt marsh vegetation as well as greenhouse gases. So for this experiment, we broke the runoff implementation into two different treatments called low elevation runoff and high elevation runoff, because the environment type where these runoffs were placed varied. The low elevation runoff area consisted of unconsolidated sediment that was predominantly bare at the start of the study. The high elevation runoff was surrounded by stable sediment, vegetated at the start of the study, and contained higher elevations than the low elevation runoff. So due to these differences, we suspected that the impacts of the runoffs would vary, so we split them into two different treatments. And so we used 12 replicates for each of these treatments, including a reference site, and we measured things like vegetation percent cover and greenhouse gas emissions. And we measured greenhouse gas emissions, you can go to the next slide, please, by using a Picaro gas analyzer. So you can see from the photo on the right, that is the photo of the Picaro. The Picaro is then hooked up to a monitor, which you can see on the left-hand side there, which then tracks in real time the amount of CO2 that is being, the net amount of CO2 that is being either taken up or being released. It also measures methane and nitrous oxide, but for this study, we focused on methane and carbon dioxide. And you can go to the next slide. So then that computer, or that you saw in that previous photo, is then connected to tubing that then goes to this gas chamber. So then the gas chamber is placed over the area of marsh that we're wanting to analyze and study. And as I mentioned before, in real time, it's able to tell us how much CO2 is being taken up or being expelled as the gas chamber is being deployed. Next slide, please. Thank you. And so just to talk about some of the main results of this study, we found that in the low elevation runoff treatment, we saw a significant increase in vegetation. So we saw more vegetation coming back, specifically Spartina alterniflora or cordgrass, coming back in areas that were previously bare. So a positive result that is shown that we are seeing vegetation recolonizing within previously bare and stressed areas, which then helps us show that the increased drainage helps to create suitable habitat for plant regrowth. Next slide. And the high elevation runoff, as I mentioned before, this already was surrounded by vegetation. But what was interesting about this treatment was that we saw the persistence of Spartina patens, or salt marsh hay. And so salt marsh hay is very vulnerable to flooding. It's not used to being flooded very frequently, and that's the type of plants that we're actually seeing decrease a lot because of the amount of flooding stress that is tied to sea level rise. But with the treatment of the runoff, we actually saw the persistence of Spartina patens salt marsh hay, which is another positive result to see that we are able to maintain high marsh habitat, which is wonderful for salt marsh sparrows, as well as many other functions of high marsh that are essential for salt marshes as well. And the next, thank you. And then for the greenhouse gas response, so as you can imagine, that as vegetation is coming back, as vegetation is being maintained, we're actually seeing this increase in CO2 uptake. So increase of CO2 removal from the atmosphere, and then which then helps us to know that runoffs can also help to maintain an important carbon sink capacity within salt marshes, because due to the vegetation being maintained or being able to come back as we're alleviating some of that flooding stress, we're seeing more CO2 removal from the atmosphere, which is another exciting result to see. Next slide, please. And so, as I mentioned before, when I worked for MassAudubon, we had a runoff project at our Allen's Pond Wildlife Sanctuary in Dartmouth. So you can see our Buzzards Bay there and Allen's Pond right along Buzzards Bay. So now I'm just going to show you some of our very preliminary results from this study, because we just implemented runoffs back in May of 2020. So it's so not it hasn't been a year yet, but we have seen some initial results that I can share with you. So some of the things that we measured for this experiment was looking at elevation, vegetation, something called micro islands, which are basically small areas of elevated peat where the material that is removed when we're creating the runoffs, we basically create these little mounds, and then those mounds vegetate over time. And they also can potentially create a nesting habitat for salt marsh sparrows. But that's one of the goals for them. They can create these kind of sanctuaries that are free of flooding stress that sparrows could use for nesting purposes. And we're also looking at water level too. Next slide, please. And so just some preliminary results. So those micro islands, or that revegetated habitat island, so that was at the start of the study, it was completely bare, just bare peat, bare sediment, and then just after one growing season, it's you can see that it's on its way to being fully revegetated. And the surface drainage right after we implemented the runoff was pretty immediate. So areas that were completely inundated with water in that middle photo, just imagine that just being a large pool of water where that exposed sediment was just completely inundated. And now you can see the runoff removed that standing water on the marsh. And we're also seeing some elvers utilizing the runnel. So another positive thing, especially for mosquito control, to see these types of nekton utilizing the runnels, coming up, eating any mosquito eggs. And so another positive result. So when we think about water levels, so let's take a closer look. The red line represents when we implemented the runnels. And so to the right of that red line, it shows the amount of water that has been removed from the marsh, or how lower the water table became after the runnels were implemented. So again, that's further highlighting the strong drainage impacts that the runnels do have, and how different it is from before the runnels were created. So we're definitely being able to benefit from being able to remove excess water, that drainage impact that the runnels are creating. Next slide, please. And so one other technique that I wanted to mention briefly is a technique called sediment enhancement. So this technique isn't practiced in Massachusetts, but it has been practiced in other states, and one of them being Rhode Island. So this technique basically uses dredged sediment material, places it on the marsh to increase elevation of the marsh. Because as we know, with sea level rise, our marshes aren't keeping pace, and so they're at too low of an elevation in a lot of cases to kind of keep pace with sea level rise. So this treatment, sediment enhancement, allows for more sediment to be placed on the marsh, higher that elevation, to make salt marshes more resilient. So you can go next slide, please. And so these are just some photos of progression of a couple sediment enhancement projects that occurred in Rhode Island. So that far left photo is what the area looks like right after the sediment has been placed. So it kind of resembles more of a beach than a salt marsh. So this is Quaney Pond in Charlestown, Rhode Island, in southern Rhode Island. So after one growing season, you can see, so most of this was planted. So this was planted. So a lot of big volunteer efforts go to actually plant salt marsh vegetation and sediment enhancement areas. And then after those plantings, the marsh kind of kickstarts the marsh, and then allows the marsh to fill in on its own, to looking something like on the far right picture, just after 3 growing seasons. This is another site, Ninigret, in Charlestown, Rhode Island. And just after 3 growing seasons, the amount of vegetation that has come back. So just giving another example of a different sediment, of a different climate adaptation technique to use to help our marshes become more resilient to sea level rise. Next slide. So this is my final slide, and I would be remiss in not mentioning the wanting to talk more about these techniques in order to relay more comfort and more familiarity with these techniques. So we often do site visits, we do tours of the restoration sites, so that people know what we're doing, why we're doing it, and the impacts and the positive impacts of these techniques, so that we can continue to do them even at a larger scale than what's currently happening. And you can go to the next slide, and just want to again thank all the folks that have led these projects, done these projects, supported me through these projects as well, and of course funding and permitting folks as well, which of course nothing can happen without money, so special thanks to them. And that's it for me.
Thanks so much, Danielle. That's just really, really interesting.
Yeah. So, yeah, I mean, and just as a final point, Danielle was just thanking, people about permitting. That is really probably the biggest hurdle for some of this work. You know, I think we're starting to get a better handle on the science now, and it's really kind of the being allowed aspect, because as you think about it, you know, the Wetlands Protection Act kind of is counter to the idea of cutting holes and runnels and things like that, and depositing sediment on marshes. So we'll be working on that just as much as we'll be working on the science. And I know we have a bunch of questions, so.
Yeah, I'll start I think this will probably go to Danielle or Sara. Can you do sediment enhancement with thinner layers of sediment that allow existing vegetation to poke through without replanting by humans?
Yes, definitely. And that's done a lot, especially within like our southern states like Louisiana and like the Carolinas. So they do a little bit more thinner placement than probably a lot of what we've done up within New England, or at least within Rhode Island, because we lay it on thick in Rhode Island, that's for sure. So that it is possible, but we also take into account the projections of sea level rise and then what elevation is most ideal for the marsh to be. And then oftentimes, because we are in a part of the world really where we are experiencing lower elevation and lower elevation marshes, so we do have to add a bit more sediment within our projects in order to make them more resilient and being able to kind of combat and withstand current and future sea level rise impacts. So we have to consider that as well.
Thanks, Danielle. This one probably to, well, Sara, and this happens on the North River too. Someone here lives in the Narrow River, Rhode Island, the Petasquamscut. As Danielle knows, there's lots of ditches there, and motorboats create lots of waves along its length. The boats interrupt herons, cormorants, ducks. Are these waves contribute to erosion?
Well, I mean, at least for the north and south, I mean, there's a reason we have a no wake zone. It certainly does not help our marsh edges. And there's no way of really knowing how much of what Tom has seen could have been influenced by boat traffic. So we don't know how much of it is due to that, but it certainly is a physical force that is regularly impacting already vulnerable marsh edges.
Danielle, when would runneling not be appropriate?
Sometimes there's marshes that are too far gone, that are too low in elevation, that experience too much flooding, where runneling just won't be as effective. So in those cases, sediment enhancement might be the best option. So areas that are just too waterlogged, have just too much inundation, where runneling might not even, it might help to drain, but still not help to bring the vegetation back. So in those situations, sediment enhancement might be a recommendation.
Okay. Thanks, Danielle. Tom, we've got a couple for you here. Is the salt marsh loss from 52 to now a continuation of marsh loss that's been going on since the opening of the new mouth during the Portland Gale of 1898?
Well, I can't say for sure, but it would seem obvious to me that by removing the bar that used to exist at the mouth would expose that front side of the marsh, or that northeast facing side of the marsh. And I would think that, yes, it's just continuing. I can show you a, in fact, let me do this. Do I have, yeah, I can. Good. Let me show you 1952 here. And, oh, did I do that right? Can you, no, I didn't. Hang on a second. I managed to, you share. Now, the question is, can you see my screen?
I can see
We're seeing our map.
Yeah.
Okay, good. So this is, let me back out just a little bit on this. This is the mouth, or near the mouth. And this is 1952. And I'm going to switch back and forth between 2021 and 1952. So this is what you're dealing with in 1952. And you can see that the edge of the marsh is approximately here. And when I turn that off, you can see kind of a ghost of what was there. And also inboard of that, you can see that there's a lot of areas that are flooded. They no longer support vegetation. So this is clearly being impacted, I think, by winter storms here. And so this is think of it as a shelf that's tilted towards the center of the channel. And there's kind of a vague line that runs here where you have more vegetation, and over here, kind of the islands are a little darker, and that's mud. So I would say that, yes, this is an ongoing process. I think you can probably expect that this sort of texture and topography, microtopography, is going to advance in this direction. And these kind of rougher looking surfaces here are going to ultimately invade this part of the marsh as well.
And just from sort of a field work and ecology perspective, we have, if you can you scroll down, like move south a little bit?
Yes, you can.
So the marsh that is just north of the road out to that island, to Trounce Island, just about sort of to the right of where you are right now,
Okay.
is a site where I've had transects since 2000, and in 2000 and 2014 they were both pretty similar, but then I tried to go out this past summer, and we're starting to see that marsh degrade to the point where it can't support a person anymore, and it's degrading from underneath. It's the peat that is starting to degrade, because the vegetation is dying off. So it's starting to happen out there more.
Yeah, I mean, you can clearly see how pockmarked it is in areas where there's no vegetation whatsoever. And that gets back to what Danielle was saying about these areas where you have ponded water and it's killing off the marsh grass. Well, this isn't necessarily ponded water. The elevation now is low enough so it's flooded for a great part of the time, probably only exposed at a fairly low tide at this point. So it's a process of, it's a gradual process, it looks like to me, that where you're losing elevation. And I guess once you get to this point, there's no saving it.
It's really interesting. Tom, I noticed that in some of your LiDAR maps, it showed inland wetlands, lower elevation areas. A question is, how do you anticipate, and I guess this could be to any three of you, how will inland wetlands be impacted by this? I assume sea level rise. For example, like in Pembroke has a lot of wetland areas.
Yeah, that kind of gets back to this issue of whether or not this area down here is, I mean, most of this is all below 6 feet, this whole area here. Most of this is wooded wetland, you know. It's hardwood and it's marsh in the sense that it's flooded, I guess, but it's all, you know, it's a wooded marsh. And this may be increasing, I don't know. I mean, again, it's hard to say from the 1958 photo, 52 photo, what this means. Oop, I guess I don't have that. Here we go. Let's see if I can turn that on. Yeah, I don't have really good coverage of this, so it's hard to say. Let me see if I can fix that a little bit. and zoom
But
in.
as I noted, you know, with sea level rise, we are expecting the tidal prism to move upstream. So we'll have higher, you know, it's still tidal up at the crotch, so we would still see tides. They might be higher than they are now, but we also will start to see more salt water, maybe not as far up as Pembroke, but certainly up into the upper parts of the brackish marsh around Route 3, where we don't have too much salt marsh right now.
Thanks, guys. This is an interesting question. So salt marshes are obviously the most valuable coastal resource on the planet, but how do we reconcile replacing the valuable and benefits of intertidal habitat as opposed to, you know, the salt marsh restoration? Is there a sort of a balancing act there?
Yes, definitely. So oftentimes when we think about salt marsh restoration, one of the things that we always consider is salt marsh migration and like inland migration and just retreat pretty much. Because a lot of the things that we're doing, it's really just buying us time. And so kind of just holding off the sea as much as we can, but to a certain point, we have to migrate inland. So thinking about that and preparing for that, we do a lot of things to help promote salt marsh migration, or at least just coastal habitat migration in general. And a lot of that is just keeping our inland sites and habitats healthy. And so that, because when that does happen, that transition can be as smooth as possible. So things like removing barriers, coastal barriers, man-made structures that are kind of bordering or within our inland environments or bordering our coastal environments, removing unnecessary barriers to not only promote healthy inland habitats, but then also help to facilitate any coastal habitat migration as well.
Thanks, Danielle. Either Danielle or Sarah, we mentioned the salt marsh acting as carbon sinks, carbon sequestration. How do salt marshes decline? How can that release carbon into the atmosphere? Can you speak a little bit about that?
Go ahead, Sarah.
Answer that question. No, you can answer it.
Okay.
You're better with that.
Oh, we'll see. So marshes, they store a lot of carbon within the soil. And because decomposition is so slow within salt marshes environments, that's why they're able to store more carbon even compared to our forested environments, because it's all about the soil. Because these areas spend so much time being wet, the decomposition is so slow, and all of that organic matter is just basically being held within all of that peat and all of that sediment. But what happens when our marsh is starting to degrade, and especially when I'll use the ditch example, when oxygen is being introduced into the soil through ditching, when our marshes are degrading, when that is occurring, all of that carbon within the soil is, once it gets introduced to oxygen, it all starts to emit into the atmosphere. So all the carbon within the soil, like once oxygen is involved, it's no longer within that state, and then becomes into this admittance of CO2 back into the atmosphere. And that's the same type of processes as the sediment just degrades on its own too, with different impacts of sea level rise. It's just not able to store that carbon within the soil anymore, so that either it usually gets released with multiple forms of greenhouse gases like methane or carbon dioxide.
The other thing that I just want to know is, you know, as people out there, you may wonder what you can do for the salt marsh. And another thing having to do with salt marsh chemistry and salt marshes degrading is that we know now pretty strongly that the more nutrients that enter a salt marsh, the more we see that peat and that underground plant material, both the roots and the rhizomes, which are the underground stems, they degrade a lot faster when they are exposed to more nutrients. And a lot of those nutrients are land derived, And so trying to limit the amount of fertilizer on your lawn that is, just uphill from a salt marsh could have a pretty good impact on maintaining the integrity of that marsh.
Good point, Sarah. Just a couple more, and these are all great questions, by the way, and thanks you guys for answering these. What can be done about the infiltration of Phragmites?
Well, I'll have Danielle chime in on this too, but we again are learning more about the role of Phragmites as a member of the salt marsh community. I think in some places where we see large swaths of Phragmites that are overtaking entire areas, those are sometimes places that are tidally restricted to begin with. But in an open marsh environment, Phragmites will generally be limited to the upper edge. And some of that is actually a remnant of that freshening effort by the initial farming projects that occurred on our marshes. But Phragmites also creates a lot of structure, and it has been found to be a pretty good carbon sink. So I think there's less focus on trying to completely eliminate Phragmites and more focus on trying to control it through salinity in the marsh environment. And I don't know if you want to add anything, Danielle.
Yeah, that's exactly right. I think we've kind of given up the notion that we'll ever get rid of Phragmites. I think it's more of like just being able to live with it and maintain and control it as much as we can. And I think runnels have been helpful for that as well, because Phragmites can grow in standing water. And so as there's more standing on water on the marsh, it creates a habitat more hospitable for Phragmites. So again, another positive note for the runnels is that as it drains water from the marsh, it actually eliminates some of that habitat for Phragmites. We also see Phragmites dying back as well with runnel use. So I think it's all about just maintaining it. And like as Sarah said, there are some positive carbon sequestration and sediment stabilization aspects of Phragmites. So I think it's all about the control as of right now.
Thanks, Danielle. And Sarah, you started mentioning this earlier as a good way to sort of end this on a positive note with reducing our usage of chemical fertilizers and things. But are there anything from any of you, anything else that the average person can do day to day to help, or places to get involved or volunteer to help our incredibly important salt marshes here in and around our communities, not just in the South River or the North and South Rivers, but elsewhere?
Slow down in your boat. There's one thing you can do. Look for opportunities, particularly as the Watershed Association moves towards doing some of these projects. You saw in Danielle's slides that a lot of that work is hand effort. It's hand dug runnels, it's planting of salt marsh grasses, and the more help we have to do those things, the much easier it will be to implement them. So keep your eye out for that. And also look out for ghost trees and let me know if you see them.
Yeah, I would just add to that too, of just getting, I'm sure this group is well involved in their communities, but just to further emphasize, like getting in touch with their conservation commissioners and like letting them know that you're interested in this work, that you're interested in these restoration techniques, because you might be surprised to hear that maybe a runnel project is trying to be implemented within your town, and being able to kind of be involved with that project and that process as like these projects go through the Conservation Commission network. So just being involved and showing your interest and your desire to learn more, and and see your marshes be restored and maintained is a wonderful thing to do.
Thanks, Danielle. Thanks, Sarah. And thanks, Tom. We'll conclude it there. Those are all great questions from everyone. If anyone has any questions that weren't answered or something comes to mind, feel free. You all have my email, send it to me, and then I'll make sure it finds its way to the proper person to answer it. Once again, thank all of you very much for joining us tonight. Tonight's fantastic presentation about making salt marshes more climate resilient. We had geologist Tom Bell. We had NSRWA Watershed Ecologist Sara Grady, also Mass Bay's South Shore Regional Coordinator. And we had Danielle Perry, Marine Habitat Resource Specialist with the National Oceanic and Atmospheric Administration. Thanks all of you for being with us tonight. It was an incredibly fascinating topic tonight. So thank all of you very much. And with that, I shout out also to our sponsors with Clean Harbors, Clear Water Recovery, and the Massachusetts Cultural Councils of Duxbury, Hanover, Marshfield, Norwell, Pembroke, Plymouth, and Scituate. Thank all of you so much for your support. We really appreciate your support of educational programs like this. Doug, did you want to say one more thing about next week?
Yeah, we would love to see as many folks as we can next week. Be great to get a chance to chat with you.
Yep. Thanks, Doug. I put a link in the chat for a registration link on that. Registration, I don't think is 100% required. There's plenty of room there, but it'd be if you do want to register in case they send you updates, something like that, please feel free. And I'll make sure to email out updates for next week as well. So hopefully we'll see you there at Stellwagen next Wednesday at 7 o'clock. With that, once again, thank you all so much for being here. My name is Brian Taylor with North and South Rivers Watershed Association and Doug Lauer with MassAudubon. And thank all of you for being with us tonight. Hopefully we'll see some of you next week. Have a good night, everybody.